if in addition to x equal 0.5 meters when t equals 0, we say that the maximum value of x is 1 meter, then we can observe that the max value of the cosine is 1, so the max value of a times the cosine of omega t plus phi naught is a. Thus, a equals 1. And now we know a, we can find phi naught. 1 times the cosine of phi sub 0 equals 0.5 meters implies that the cosine of phi sub 0 be 0.5 meters, and this is 1 meter, not just 1. 5 meters over 1 meter, which is 0.5, so that phi sub 0 equals the inverse cosine of 0.5. And inverse cosine of 0.5, as we know, is 60 degrees, or pi over 3 radians. Now we're going to use the radian measure, and we're going to pretty much use the radian measure throughout anytime we do calculus. But we'll indicate for right now, just for quick reference, that that's 60 degrees, and you should understand that the cosine of 60 degrees is 0.5. The implications for the motion of the object, well, as you will know if you are familiar with the circular model for the trigonometric functions, again, you should be. If not, there's plenty of review material in my second semester pre-calculus, which I can refer you to at any point. And you can, of course, find this at a number of other websites. Okay, what this says is that if this is a reference circle of radius 1, and let me use the Sharpie here. Okay, this will have radius 1. Then this motion, described by x equals a cosine of omega t plus phi naught, represents the x-coordinate of a point moving around this circle at angular frequency omega and starting at the pi over 3 or 60 degree position that we found here. Now, pi over 3 position is here. So here's angle pi over 3. If we're at this position, then where's our x position? It's here. So here we have x equals cosine of pi over 3, which is 0.5. That just matches our specified initial condition. We'll go on with the circular model in a minute.